We understand that two objects are said to be congruent if they have the same shape and size. But what is the purpose of studying congruence? How is it useful? Let's discuss some examples where concept of congruence is applied. What do we have here? Here we have a die used for making candles. With the help of this die, we can make a large number of candles with same shape and size. The same die can be used for making candles of different color, but if we want to change the size and shape of the candle, we have to change the die. This is where we apply the concept of congruence. If we want all the candles to be congruent, then each groove in the die should also be congruent. What kind of information as a manufacturer we should have so that each groove in the die is identical? Should we know the shape and size of each groove? Yes, but is that enough? No, that is not enough. We should know the dimensions of each groove. But should we know all the dimensions? No. Only certain dimensions are required for determining the congruency of the grooves. The study of congruence and its deep understanding helps us in knowing basic rules and sufficient conditions of determining congruence of objects. Let's see a very interesting application of concept of congruence. Here, we will measure the width of the river without crossing it. How do we do this? We will apply the concept of congruence. Let us suppose we are standing here on the left bank of the river, and this is the width of the river AB, which we have to find out. We will mark any point M here on the left side only, join points M and A, and mark its midpoint as point O. From point M, start moving in a perpendicular direction to AM. So we will move in this direction. We will move until we reach a point N, so that N, O and B are in the same straight line. We can join N, O and point B with a straight line. Now my straight line here doesn't exactly look a straight line, it is crooked here, but you can assume it to be a straight line. When we do this, then length MN will be equal to width of the river AB. How does this work? Well, by rules of congruency, we can prove that triangle NMO and triangle OAB are congruent to each other, and when they are congruent, their size will be same, and when their size is same, their size will be of same length. That means NM will be equal to AB. So this length is equal to this length. So this is a very interesting application of concept of congruence. Here, without crossing the river, we can measure the width of the river. We can use the concept of congruence for determining area also. So here we can see we have hexagonal tiles. How will we determine the area of each hexagonal tile? Well, here each hexagonal tile can be divided into 6 triangles, and by rules of congruence we can prove that all these 6 triangles are congruent to each other. If all the 6 triangles are congruent to each other, that means they have same size and shape. That would imply areas of these 6 triangles will also be equal. What we have to do here is we just have to find area of one triangle and multiply this with 6 to get the area of each hexagonal tile. Congruence is also used for proving geometrical properties. Well-known properties of parallelograms, squares, rectangles, triangles and circles are proved using congruence. For example, if we have to prove that diagonals of a rectangle are equal, we will make use of congruence. Similarly, in case of circles, if we have to prove that tangents drawn from the same external point are equal in length, once again we will make use of congruence. Let's summarize what we have learnt here. Congruence is required for proving well-known theorems of geometry. Congruence has several applications in real-life contexts also.